This is question number 28 on the Algebra 2 Common Core Regents from January 2017. And what we have here is an exponential growth or decay question. And all this is saying is we need to determine whether this given function is growth or decay. Now, if we are versed in chemistry or physics, we'll recognize that this is a half-life equation. And of course that would be a decay function because the mass of radium would decrease rather than increase. But forgetting that for a moment, let's consider this purely from the mathematical standpoint. So one of the ways that we could do this is we could actually graph this function and see if it increases or decreases over time. So let's do that. Now we have to be careful putting in the exponent here. And again, if you have the updated version of the software on your calculator, then you can put in the fractions. Otherwise, you have to be very careful with your parentheses to make sure that they are reasonable. That should do it. And I have the zoom set in a very bizarre spot, so just bear with me for 1 second. Now you'll notice that here the function doesn't show up, so we have to play with the window a little bit to make it show up. So I'm going to change this back. You'll see these numbers are quite large. I'm going to change this to maybe about, I've got 1590 here, so the number that t will affect is actually going to be pretty big. So why don't we make this about 5,000? And we'll start with a y of 0 and go to a y of, well, we're starting with 100, so why don't we start there? Let's graph that. And it surely looks like a decaying function. Okay. Now, once we know that it's decay, either by knowing that from chem or physics or by graphing it, let's examine why and how we can explain that. So the first thing that you can do is you can actually sketch this function and then show that that is decay. Now, I'm not entirely positive that this is going to be sufficient. So let's explain it using the algebra concepts. So what we have is m of t is 100e to the ln of 1/2 t over 1590. Now it's important to recognize this whole thing here is the exponent. So from our knowledge of exponential growth and decay, we should recognize that if the exponent is positive, it is growth. If the exponent is negative, it is a decay function. What that means is as t increases, if the exponent is positive, then the whole value will get larger. And if t is negative, then we'll have if as t increases, the whole thing gets smaller, then it's a decay function. So let's get the value of our exponent. So the value of the exponent is ln of 1/2 over 1590 times t. So let's get this constant, ln of 1/2 over 1590. And what we've got is a negative number. It's negative 4.35 times 10 to the negative 4th. So the function can then be shown as m of t is 100e to the negative 4.35 times 10 to the negative 4th t. Since the exponent is negative, this represents a decay function. And this is, again, more than enough to get you full credit on this question.